Okay, so here we're going to talk about Newton's first law, which is an object in motion stays at motion unless acted upon by an unbalanced force, and an object at rest stays at rest unless acted upon by an unbalanced force. So, in this example, I'm going to show you when I threw a frisbee up in the air and then threw a basketball at it, how the basketball disrupted the frisbee's velocity. So, here we go. Okay, so I played at a half speed so you can truly see what's happening. So as I throw the frisbee up, you can see that it's traveling at a constant velocity, and it keeps on traveling until I throw the basketball at it, and it hits it, and it causes the frisbee to accelerate to the left, as you can see right there. Once they meet in the middle, that's the point where force is exchanged and causes the frisbee to accelerate. Okay, so this can also be an example of Newton's first law because once my partner throws me the frisbee, it's traveling at a constant velocity towards me, and as I step towards it, I catch it, and my hand, or just me in general, stops its velocity, causing it to accelerate. So you can see right here, as I catch it, the frisbee stops moving until I drag my arm down, and therefore I'm moving it, and so that's a different thing. Increase the force on a certain object, its acceleration will increase, and if you increase a certain object's mass, then the acceleration will decrease. I threw the same frisbee at two different forces, and you'll see which one accelerates farther, or goes farther, sorry. So here, this first shot, you see that I throw it pretty far. It lands all the way at the top of the hill. And then in the second shot, you will see that it doesn't go quite as far. And this is because of the difference in forces. So in the first one, you could really see that I'm really into it. I step into it, I wind it up more, and so that gives me a greater distance. And then in the second video, you see that I'm not as into it. I just take a small step right here, and I just give it a little flick, not really too hard, just enough to give it a bit of distance. And it doesn't go too far, just at the middle of the hill. Here we're going to see Newton's third law, which is every action has an equal and opposite reaction. So in this video, you'll see that my partner threw me the frisbee, and as I went to go catch the frisbee, I hit it with my thumb right there. You can see that I was reaching out for it, and it didn't fall into my hand. So instead what happened was it caused the frisbee to accelerate more in this direction. So the part about Newton's law that says every action has an equal and opposite reaction means that once you hit something and it hits you back, it's the same amount of force, but the difference may be that an object has more mass or less mass, causing it to accelerate or accelerate less. So right here, right when my finger and the frisbee met, that's when the forces were exchanged, and it's the same amount, they're equal. So I hit the frisbee, and the frisbee hit me back, and they're equal. But the difference was that my hand has a larger mass, so it wasn't affected as greatly, so that's why the frisbee kept on going. So physics is a really important science. It is one of the sciences that explain why things move and why we stay on Earth, why we don't float away. We learn at a young age that if you're heavier, you kind of run slower, or if you carry a grocery bags and try to run, you can't run as fast as you usually can. And we also learned that if you push something down a hill, it moves by itself. And I don't know about you, but I've always wondered why these things happen, and I like physics because it explains these. Physics also gives us the answers without complicated equations or mystery sciences that we can't see with our own eyes, so I think it's easier to relate to it. Physics is in our everyday lives, so I think it's really, really important to know even the basics of physics. So yeah,